All right, so I am going to now demonstrate how to calculate some structures for a simple house addition. As part of this class, we have this Revit model. I also teach Revit, and we've developed this Revit model for a house in which we're going to be putting an addition somewhere in here where you see the driveway. We're going to be sizing several members in there. They have already been sized, but we're going to check whether they are correct or incorrect and what the process for it is. Here, I'm just going to cover the very basic process mindset prior to sizing the members. So the first thing is I'm going to show you what we're going to be doing. So the addition is going to be uh, all of this right here. If I change the color of the existing versus the proposed, so that you get a closer look at what the addition looks like, it's something like that. So everything that's gray is existing, everything that's red is new. It's a very, very sizable addition. If you think about it, it's actually the same size as the existing house, if not bigger. Um, and we're gonna be having a three-car garage in here, a master bedroom above it, and a gable roof with a cathedral ceiling. Um, what do I do? Well, the first thing I do is I set up a very clean sheet where I show how I think the members are gonna go. This is a mental process. This is not something. There's no right or wrong way of doing it. It's more like a process as to what's the most efficient way of framing this. So the first floor, we believe that should be framed this way. So the joists are gonna go this way, and we're gonna have LBLs going this direction, so that we shorten the length of them. So we want to use 2x10 floor joists throughout the whole project, and we're gonna be using at least 1, 2, and 3 LBLs. The first thing I want to know is after I determine how I'm gonna frame it, I like to determine the spans of all of these members. So what do I do? So I start placing dimensions on the main support members from one to the other. Once I determine this, so we know that this 2x10 is going to be spanning 13 feet, this 2x10 is going to be spanning 13 feet, and these ones are going to be spanning 10 feet. Then the other thing I want to know is how long is my main support members going to span, and these LBLs have a length of about 26 feet. So after I determine that, what I really want to show you is how much is each one of these LBLs actually supporting. And the way to know what they're supporting is very simple. So I'm going to be doing a very bold red line to just show you what they're supporting. So this LBL right here, and we can call that LBLA. LBLA goes all the way from this spot to this spot, spanning about 26 feet, 3 inches. And it's supporting half of the load from this direction to this direction, because this wall is supporting half of this load. So what I do typically is I draw a line and show what is my tributary width. That's what we're going to call it. All right. So the tributary width of this member is half of the span of this floor joist. So it's supporting about 6'7" of that side. And if we do a little annotated line so that we can clarify what that really looks like, it looks like something like this. So I'm going to do a hatch and say the tributary width that this member is supporting is this one. That is the tributary width. I'm actually going to represent it. That's actually bold enough. So that's that tributary width. And then, so the same procedure goes for this one. So what's the other tributary width that this member is supporting? So it's supporting all the way from here to there, but it's only half of that that's being supported by that member. Okay, so we're going to be sizing that member right now. Okay, so we have tributary width, it's supporting this much. Okay, so I do this element right here and say, okay, let me just illustrate it. So it's supporting from here, all the way there, all the way here. So this LBL is spanning 26 feet 3 inches and is supporting 5 feet on one side and 5 foot and 6'7" on the other side. This is the first exercise into knowing what this member needs to be and whether this member is accurate, proper, or not. So I'm gonna hold it in here, and then I'm gonna go into my structural calculation software to show you how I can verify whether this two LBLs, two of them, 1 3/4 by 11 and a quarter microlamp, whether they're proper or not, and whether they work or not. Okay.